Hello, welcome back. In this video, we'll discuss the classification of optical fibers. Optical fibers have been classified basing on three different parameters. They are classified using the refractive index profile as a parameter. They are also classified using the number of modes that they support as another parameter. And the material that is used to fabricate the optical fibers is also used as a parameter to classify the optical fibers. Optical fibers can be classified into two basing on the refractive index profile. The first one is step index fibers. The second one is graded index fibers. Similarly, based on the number of modes that an optical fiber can support, optical fibers have been classified into single mode optical fibers and multi-mode optical fibers. Basing on the material used to fabricate the optical fibers have been classified into glass fibers, plastic-clad silica fibers. We shall look at the refractive index profile based classification. Before understanding the refractive index based classification, let us try to understand the refractive index profile. Suppose you have an optical fiber like this with a core of so much of diameter and cladding all around that. We know that the refractive index of the core should be higher than the cladding. We are trying to plot the variations in the refractive index as a function of radial distance from the axis of the core. This is the axis of the core. So throughout the core we have the constant refractive index, and suddenly the refractive index changes when you enter the cladding region. Clad is having less refractive index, so we have a step-like function. Since the refractive index is changing in the form of a step, we call such refractive index profiles as step index profiles and such optical fibers as step index optical fibers. The refractive index profile of an optical fiber is a plot of refractive index variations as a function of radial distance from the axis of the core. If the refractive index changes in the form of a step, then such optical fibers are called as step index fibers. Similarly, we also have graded index fiber. In the case of a graded index fiber, the refractive index within the core will have several gradings. Means the refractive index of the core decreases smoothly and slowly as you move towards the outer edge of the core. So these are the smooth variations we have. And the cladding again will have a constant refractive index. If you have an optical fiber for which the core refractive index changes smoothly as you move away from the axis of the fiber, then such optical fibers are called as graded index fibers. Graded index fibers are for short green fibers. Now we shall look at how optical fibers are classified basing on the number of modes they support. Optical fibers are classified basing on the number of modes they support into single mode fibers and multi-mode fibers. Before try to understand what single mode and multi-mode, we shall first of all try to understand what a mode is. A mode in optical fibers. We know that the core of the optical fibers is small, maybe about 10 to 100 micrometers, and when the core is comparable with that of the wavelength of the light that is being used to transmit the signal through the optical fiber, then the launched electromagnetic wave will excite certain electric and magnetic modes in the optical fiber. A mode essentially means a well-defined pattern for the electric and magnetic fields across the core of the optical fiber. A mode essentially means well-defined pattern for the distribution of electric or magnetic or a combination of electric and magnetic fields across the core of the fiber. A mode essentially means a well-defined pattern for the distribution of electric or magnetic or a combination of electric and magnetic fields across the core of the fiber. If the field is distributed in only one particular pattern in an optical fiber, then we have the single mode optical fiber. Similarly, if the launched light can excite several number of patterns or several number of modes for the electric, magnetic or electric and magnetic fields, then we call such optical fibers as multi-mode optical fibers. If only one mode can be excited with the launch of electromagnetic wave or light, then such optical fibers are called single mode fibers. Means they support one and only one mode, which also means that a small amount of light can enter into the optical fiber. Since only one mode is excited, the core of the optical fiber will be very, very small when compared to the multimode optical fibers. If more than one electric or magnetic modes can be excited in an optical fiber with the launched light, then the fiber is called a multi-mode optical fiber. In this diagram, we are showing the difference between the single mode and multimode optical fibers. The cross section of a multimode graded index fiber looks something like this, with a thick core and reasonably thick cladding, and the refractive index profile is shown here. All across the cladding, the refractive index is a constant, and within the core, as you move away from the axis of the fiber, you notice that the refractive index slowly decreases and reaches the value of the cladding. Using the ray theory, one can draw the light propagation in a multimode gradient index fiber in this fashion. The ray slowly bends and touches the interface separating the core cladding. The ray starts bending slowly and it propagates through the optical fiber like that. And in the case of a step indexed multimode fiber, core of the fiber is quite thick and the cladding is also thick. Refractive index is in the form of a step. Here you have a step. Suddenly the refractive index is changing, and all across the core it is a constant. And when you plot the ray diagram, you also see that the ray suddenly changes its direction because the ray is undergoing total internal reflection into the core. As a result, sudden changes in the path of the ray can be seen in the multimode step indexed fiber. In the case of a single mode fiber, the core of the fiber is quite thin. It's very small. It's about 10 micrometers. Ray diagram cannot be used to explain the single mode fiber. Loosely, we can say that the ray moves along the axis of the optical fiber. Now we shall see the classification basing on materials. There are three different materials that are used in the fabrication of optical fibers. They are, first one is glass. So in this we have glass core with glass cladding. The second type is plastic fibers. In this, plastic core and plastic also is used for the clad. Thirdly, plastic core, plastic clad silica fibers. In this, glass is used as the core material and plastic as cladding. We have all glass fibers, means for the core and cladding we'll use the glass. So glasses of refractive indices are generally used to fabricate the optical fiber. If the core of the fiber and the cladding of the fiber is a glass, then we call such fibers as glass fibers. If the core and cladding both are plastic, then we call such fibers as plastic fibers. And if the core is a glass and cladding is a plastic, then we call such fibers as plastic clad silica fibers. In this video, we have started our discussion by understanding what is the refractive index profile. We have said that it is a plot of the variation of refractive index as a function of radial distance from the axis of the core. Basing on the refractive index profile, we have seen that fibers can be classified into step index and gradient index optical fibers. We have also seen the classification based on the number of modes. There are two different optical fibers that are possible. One is a single mode optical fiber, the other one is multi-mode optical fiber. We have also seen what is a mode in optical fibers. We have seen the difference of refractive index profiles and the mode propagation in single mode fiber, multi-mode step index fiber, multi-mode gradient index fiber. We have seen how optical fibers are classified basing on the fabrication material. They are classified into glass fibers, plastic clad silica fibers. Thank you.